Alrighty, so today's lesson, we're just going to kind of continue with yesterday's permutations. So consider the following scenario. Doug, Anthony, Dan, Natasha, Gabby, and Erica will all be seated at the stage at the end of a year awards ceremony. How many different ways can they be seated if? First, there are no restrictions. So that basically means that I've got a permutation because order matters. I've got 6 students, all 6 are sitting. That's the same thing as a 6 factorial, which is the same thing as saying 6 times 5 times 4 times 3 times 2 times 1. Okay, so the answer here is going to end up being 720 ways. If you think about something that we've called in the 8th grade the box method, the idea is here are my 6 seats, and I have 6 kids to choose from to sit down first. And then when one kid sits down, there is 5 kids left to sit. A second kid sits down, there's 4 kids left. A third kid sits, 3 kids left. It's really essentially this being shown again, but kind of explaining why it's happening. Let's try this one. The row has to begin with a boy and has to end with a girl. So again, I've got restrictions now. There are 6 seats. There must be a boy in this seat, and there must be a girl in this seat. Well, in terms of the boys, I have 3 boys to choose from. Remember, these are people to choose from. I have 3 boys to choose from. I have 3 girls to choose from. Well, how many seats have been occupied? And the answer should be 2. Well, if 2 students have sat, how many students are still left standing? 4. Another student sits, boy or girl, nobody cares. Then 3, then 2, then 1. Don't forget, this is all about the counting principle. So if a boy has to be at the beginning of the row and a girl has to be at the end of the row, then there are 216 options of seating arrangements. Okay. Anthony and Gabby must sit in the middle 2 seats in that order. Okay, so we have another interesting restriction. There's 6 seats. Now, the middle 2 seats are right here. And in the middle 2 seats, it says Anthony and Gabby must be in those seats in any order, which means this seat could be Anthony or Gabby. This seat could be Anthony or Gabby. Well, when one person sits down, either Anthony or Gabby, remember there's 2 of those kids, 2 of those guys could sit down there. Only one really does. If Anthony goes down, then only Gabby is left. If Gabby goes down, only Anthony is left. So there's 2 people to fill those middle seats. When one of them sits, then there's only one left to sit. So now Anthony and Gabby have seated. They're in their seats. Well, how many students are left to go in the first seat? 4. 1 sits. 3 left. 2 left. 1 left. So the idea is the answer here would be there would be 48 possible arrangements. Let me kind of show you another way to do this. It maybe makes more sense. I don't know. Maybe it does. Maybe it doesn't. We could do this. We could say 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6. In other words, this would have to be Anthony. This would have to be Gabby. This would have, let me put that on the bottom. This would have to be, whoopsie, 1, 2. This would have to be Anthony. This would have to be Gabby. Or this would have to be Gabby. This would have to be Anthony. Right? They have to be in the middle 2 seats in any order. So there's only 1 Anthony and 1 Gabby. There's only 1 Gabby and 1 Anthony. 2 kids have sat. That means there's 4, then 3, then 2, then 1 left. 4, then 3, then 2, then 1 left. Don't forget that or means to add. If I take this left-hand side, 4 times 3 times 2 becomes 24. 4 times 3 times 2 becomes 24. But this still gives me 48 kids. So you need to decide which way is easier for you. In one string of seats, you can put Anthony or Gabby in the middle, or you can do 2 separate arrangements where Anthony comes first and Gabby, or vice versa. Alrighty, so let's kind of get this out of this big one. Let me move this if I can. There we go. Okay. Next one, boys and girls must sit in alternate seats. So for boys and girls to be in alternate seats, I'll do it the long way. I think the long way makes it a little bit more sense. So I could have boy, then boy, girl, right? Or I could have girl, boy, girl, boy, girl, boy. Those are the outcomes, right? Boys and girls in alternate seats. Well, initially, there's 3 boys to choose from, 3 choices. 1 boy sits down, 2 boys left, 1 boy sits down, 1 is left. Same thing's going to happen here. 3 boys to choose from, 1 sits, last sits. Girls, 3 girls to choose from, 1 sits down, 2 left, then 1. 3 girls to choose from, 1 sits down, then 1. When I multiply these things out, I basically get 36 over here plus 36 over here, or 72 different arrangements. Okay, let's try the last scenario. Erica and Doug must sit on the ends. It doesn't tell you how it has to be, but it's going to be either Erica and Doug, or Doug and Erica. There is only 1 Erica and 1 Doug. That's 2 kids. Once 2 kids sit, there's 4, then 3, then 2, then 1 left. Same thing here. There's only 1 Doug and 1 Erica. Once those 2 kids sit, then there are 4, 3, 2, 1 left. 4 times 3 times 2 is 24, or 24, 48 different ways we can make arrangements. Okay, so that's all that you're doing. So you might want to write the stuff out and fill in the blanks of who's still standing and who's sitting, and you should be good. Good luck on the